Hello! Welcome to the first lesson in this course, An Introduction to Stata. My name is Sean, I'm an epidemiologist, and I've been using Stata for about 10 years. And I've been teaching Stata for quite a number of those years. I think that's probably all you need to know about me. This course is, as it says, is an introduction to Stata. We're going to get you familiar with bringing data into Stata, looking at it, summarizing it, manipulating it, creating graphs, and in general learning how to code in Stata to manipulate the data to how you need it to be in order to do other things with it. So each lesson is going to be me talking for a while, and then there's some exercises for you to do, and then we'll go through the answers. The course book for this course is available on my GitHub page. That should be linked just below this video. The videos are also posted to my blog. If you're on my blog, hi. My Twitter handle is also posted below the video, so if you have any questions, just ask. And everything is free, but I'll put a donate link below the video as well, just in case people want to do that. Okay. So this first lesson is just getting started. It's a gentle introduction, including why we use Stata, how its interface looks, a little bit about do files, that's the scripting files that Stata uses, so you can record all the commands you put into it. Look at how to load in and save data, how to make use of the help system. Stata is a very good help system. How to set the working directory to save time, using the data browser and editor, that's making Stata look like a spreadsheet, and then importing, exporting, appending, and merging data. So it sounds like a lot, but it shouldn't take too long, hopefully, to get through it all. So I'm now going to make my video smaller. I'm going to leave it up because this is, there's a lot of talking in the Introduction to Stata courses, so it might help to be able to see my face. So I'll make it smaller and just move it whenever we need to when using Stata. Okay, so I've loaded up Stata and made myself nice and small in the corner. So let's talk a bit about why we use Stata. If you're following along in the course book, then it's section 1.1. Stata, general purpose statistical package, similar to SPSS and SAS, also R, and in some ways Python. I in particular use Stata because it's quick, its data handling capacity is really good, the graphics are pretty good, they're not the best, but they make professional quality graphs. Users of Stata can write new commands, so Stata can be and is constantly updated with new stuff, as well as everything that Stata does, kind of core Stata commands, where the Stata programmers write new commands. And the final reason is that writing code for analyses using Stata is, to me, both intuitive and quite easy to understand, especially when compared to other things like R and Python. In particular, the help files for Stata tend to be really good, and it doesn't take me long to work out how to use a new command using those help files. Compared to R in particular, it takes ages. So, how do we use Stata? The kind of the recommended way is to use fully just write out commands, make Stata do things using text. You can see down at the bottom here, there's a command window, so you type commands into there, and then stuff happens in Stata. You can also use do files, which we'll talk about in a little bit, but do files record all the commands that you put into Stata, and you can run the commands from there. So you can also use Stata as a kind of point and click type program using these bars up here. I don't recommend it because it's much harder to both learn Stata and learn to code in Stata and make everything that you do replicable if you're using the drop-down boxes. It's fine to do like occasionally, or the first time you do something, if you want to create a distribution or graph, for instance. It's a good way to learn how to do things, but after that point it can be much more effective to write out the code yourself. Okay, so throughout the workbook, I've written all the commands in Stata in the bold courier font. So if it's bold and it's online by itself, that's a command that we give to Stata to make it do something. It's also the same font that is here. So most of the commands in Stata follow the same syntax. You definitely don't need to follow along with this part. It's just an example. But we have some command, and this is generally a single word in Stata that gets it to do a particular task. We then give it one or more variables. These are the columns, or what the columns are called in Stata. And then we have if in, which allows us to restrict the data that we want to apply the command to a specific number of observations, and we have a whole lesson about those. Then we have a comma, because in Stata we have our main command, and then we have a comma, and then we have any options that come afterwards. There can be loads of options or no options, and the options could be mandatory or they could be optional. So you can have mandatory options and optional options. But whenever it's an option, it comes after a comma, and then some options. And they're very much command specific. Okay, if we type that in and try to run it, nothing happens because there is no command called command in Stata, and whenever you put command in that's not recognized, Stata gives you an error message. This command is unrecognized. A lot of the commands in Stata can be shortened, so whenever I introduce them, I'll use them in full, and when I'm speaking about them, I'll try to use them in full, but I'm very used to using sum instead of summarize, tab instead of tabulate, but I'll try to use it in full. In the course book, I use the full name for the first time I use it, and then any short names after that, because it just saves you time to write the short name. Okay, on to section 1.2. Stata's interface. This is Stata. You probably already worked that part out. On the left, we have the review window, and this lists all the commands that we've previously put into Stata in this session. When you close Stata and reopen it, this window will become blank again, and it will fill with commands as you type them in. The big window in the middle, that's the results window. So whenever you try to do something in Stata, the results of that action will appear here. Sometimes you have commands where there are no results, nothing appears here, but it will still list what you typed into Stata. On the right, upper right, we have the variables window. Currently, there are no items to show because we have no data in memory. Once we do have data in memory, this is going to list all of the variables in our data set and the variable label. I always recommend having variable labels because they're more informative than just whatever the variable is called in Stata. Down on the bottom right, we have the properties window. The properties window is kind of summary information about the entire data set. So it's got a list of information about the variables, a list of information about the data itself, and overall, this tends not to be the most useful window. So I'm going to stick. Yep, I've definitely got the video, definitely got the video down here because this tends not to be a very useful bit of information. Finally, we have the command window where you type in the commands to make Stata do things. Okay, section 1.3, do files. So we can type commands into the command window. We can also load up a do file. And when you look up at the top, you can select new do file editor open it up, and it brings up this kind of blank notebook looking window. It's actually a separate window. And you can type commands into Stata from here. So anything that you can write in the command window down here, you could also put in a do file. If I wanted, I don't have any variables loaded, but if I wanted to run a command, I type it in, I will zoom in a little to make it readable, command and some variable. To make it run, in the command window, I would just click enter and it would run. In a do file, I would select the command I want to run and click this button here, execute selection, will do. Alternatively, I could press Ctrl D and it would do the same thing. If you wanted to run the entire do file, you don't highlight anything and you just execute it, and it will run everything. In the videos, I'm going to be typing exclusively into the command window, I think, because it's a lot easier than going backwards and forwards between the do file and Stata. But if you're following along, I recommend using a do file so you can save all the commands that you're typing in, and it's kind of easier to pick up on any errors that you might make when typing out the commands. But yeah, it's up to you, however you want to do it. Yeah. In practice, I always use do files because you can save them, and then all of the commands that you've written are then available. If you've made a mistake, you can go back and fix it. Using do files, you never really lose data unless you explicitly overwrite it. So I often start off with one master dataset, have a whole bunch of commands, so several thousand lines long sometimes, manipulating that data, doing analyses on it, and then saving the result at the end with a different name. So I never overwrite the initial dataset. This is a really effective way to work, and it means that certainly when doing academic papers, I send off the code along with the manuscript, and people can look at it and tell me this is wrong, please fix it. Or they can look at it and be reassured that the analysis is correct. Just one thing to note, when using do files, you can make comments. So if you wanted to make a comment rather than an actual command that Stata wants to run, you can put an asterisk, and then this is now a comment. That won't run as a command, so it won't interfere with what Stata's doing. And you can see it's turned green as opposed to the black for regular commands. You can make an entire section a comment. You can make an entire section a comment by, there we go, putting in a / and an asterisk, and anything after that until the closing asterisk and / is comment. So this is entirely comment now. So if you wanted a block of text to describe what you're doing, this is how you create a block of text to describe what you're doing. Finally, you can put a comment after a command on the same line as long as you put 2 / in. So you can put a comment like that. One thing to note is that if you have 3 slashes, command continuing. 3 slashes to Stata means this command continues on to the next line, and you can do that infinitely. So if you want your command to run onto the next line because, say, you've made the do file a bit narrow, you can put 3 slashes in and keep going with the command. The command will only end when it reaches a line that doesn't have 3 slashes at the end. Okay, that's everything I want to say about do files, and I probably won't reload one for the rest of this course. But yeah, I do recommend using them because they're they're much easier to work with than continuously typing things into the command bar. You can also save them. So you can save them as a distinct file, which means you can open it as a distinct file later and continue using it. Okay. On to section 1.4, the data set. So I've created a simulated data set that we'll be looking at for this lesson. There's no personal identifiable information. It's completely generated by random chance using Stata. So there's no confidentiality issues. Feel free to do whatever you like to this data set. It won't matter. It's got 17 variables in it, so 17 columns of information, and we'll be doing stuff to basically all of them at some point during this course. And there's plenty of things wrong with it initially, so there's plenty of things that we need to do to it to make it usable. So section 1.5, loading and saving data. To get data into Stata, the easiest way, possibly, is to use the Open button and select the file that you want. So all this data should be online in my GitHub, linked at the bottom of the video. So select it, download it all, save in a location that you can access, and then we're going to load in lesson_01. Incidentally, there will be more than 5 files in the downloads folder, but these are the only ones relevant for this particular lesson. So I've opened up the file, and when you open up a file in Stata, it gives you the command it used in order to do whatever it is it was doing. So in this case, instead of having a command called open, Stata has a command called use. So it's written out the command, it's written out the location of the file that we just opened, so yours will look different to this, but still have lesson_01 at the end. And there's a comma, which means there's an option, and this option is clear. This option just means, it tells Stata that we don't mind that there might be data already in Stata. We're going to overwrite it because we now want this data set to be open. Because Stata has given you the entire command, you can copy this into a do file and use it. Alternatively, we could have typed it into the command bar to achieve the same effect. Nothing changes because it's the same file. But you could have written all this out in full to load in a dataset. Third way, final way to load in a dataset is you can, there we are, navigate to the folder that you want, select the dataset that you want, and drag and drop. And it does the same job. It doesn't have the clear command in this time because it would have prompted us, do you want to overwrite data in memory, if the data in memory wasn't already nice and saved. So if you'd done anything to the data in memory, it would have prompted us and made us select an option for overwriting the data or not. Okay, at this point, important to note, Stata has no undo button. So whatever you do in Stata is a permanent change. I think this is true for all versions of Stata, even up to 16. So part of the reason for using do files is that we never accidentally overwrite data or lose anything that we particularly need. So just bear in mind, no undo button. Also bear in mind, file paths and other strings, so list of words, characters, anything that's not just straight numbers, will usually need to go in quotation marks in Stata so it doesn't get confused. The spaces that most of us have in folder folder paths or file paths to Stata mean we've given you one bit of information, Stata, here's another bit of information, and another bit, and another bit, and it just keeps going. So whenever you want to use a string bit of text, put it in quotation marks. The exception being variable names and commands, which Stata understands as being variable names and commands. Okay, we've loaded the data into memory using our use command, and you can see the variables window has now filled up with variables. var1 is actually an ID number, it's just not named very well. We've got age, sex, height, weight, etc., all the way down to date of BP measurement. Yep, so you can see this bit of the variables, the properties window, and it shows us the name of the variable, the name of the variable, the label of the variable, its type and its format. We go through type and format in different, in later lessons. They're relatively important, not massively at this point. If I move myself, there we go. You can also see that the properties window now has actual information in its data section. So we've got the file name, number of variables, number of observations. So variables, remember, that's the number of columns, and observations, that's the number of rows in a spreadsheet, as well as how much size it takes up on computer memory, and the computer memory that's, I think, Stata is actively using right now. Let's move that back. Okay, in the course, no. Okay, we're now going to save a copy of the dataset to mess around with, to work with, keeping this lesson_1.dta file as completely separate. We're not going to touch, we're not going to change that in any way, so we always have a master copy to work from if anything goes wrong. Incidentally, the .dta file format is a general Stata data file. If it's .dta, it can be loaded into Stata, and it's a data file. So, saving a dataset is pretty much as easy as opening a dataset. If you just wanted to save over the dataset, we would click Save, but we don't. We're going to save it as something so that we can make changes to it and be certain that we're not losing data by doing so. Often I just do underscore and then my initials. Feel free to use your own initials, not mine. And then that means, there we go, that means we have another copy to work from. The command in this case is simply save, and then the folder and the file name that you want to save it to, and there's a bit of output as well, and it tells us that the file has been saved. Good. In the course book, I've included curly brackets around things like folder and initials. Anything in curly brackets in the course book is things for you to change and fill in as necessary. So in this case, you need the folder location that you want to save the data to, and your own initials. Okay, so if you didn't include the folder location there, it still would have saved the data set. It just would have saved it to your current working directory, which we talk about in a little bit, but for now is the location just in the bottom left-hand corner of your screen. In my case, it's just my normal C drive documents. Okay, section 1.6, help. So Stata's help system is nice and extensive. Every command has its own help page, and in general, the help pages are really good. They have examples, they show you what you need to type in order to make different things happen, and there's rarely been cases where it hasn't been complete enough for me to work out what I'm supposed to be doing. So, we've seen the commands use and save now, use and save. If we wanted to know more about them, we could type help, and then the command that we want to know more about. So in this case, let's look at the help file for save. There we are. Let's make it big. Can we zoom in? No. Okay, never mind, we can't make it big. On your own screen, you should be able to see it nice and fine. So we have the command and what it does. In this case, save the Stata dataset. Fine. The syntax in Stata is the kind of grammar of how to use a particular command. So it tells us that we need to type the command name, save. Anything that's underlined is the short form of the command name. So instead of typing out save, we could write SA without the VE, and Stata would understand that means save, because the SA is there's no other command in Stata, surprisingly, that starts with SA, so it knows that it must be save. We then have something in square brackets. Square brackets in Stata language means optional, so you don't actually need to put in a file name, but it just requires any file name. If you typed save without the file name, it would just try to overwrite the current file in memory. And then we have more square brackets and a comma. So these are the options for the save command, and they're optional commands, optional options, sorry. And I suppose if we clicked on it, it would take us just a little bit down into this section here, which is all of the options you can have for the save command. Stata does sometimes have different ways of expressing the command. In this case, save old saves the data in memory to a file in Stata 13, 12, or 11 format. So this is a slightly older form of the Stata data file system. I've used Stata pretty interchangeably between different versions, and it's never been a problem. But if you find that you're saving data which doesn't then load in a different version, save old might help. The options also have also underlined in their shortest possible command form. So instead of typing no label, you could type null. Instead of typing orphans, you can type O. Each option is usually pretty well described. We don't really need to know all of the options other than replace, which overwrites an existing data set. So Stata won't overwrite anything in general unless you give it a specific command to do so. So when we use data, we need the clear option if we have data in memory already, and if we're saving data, we need the replace option if the file already exists. If we scroll down, we then get a description of what the command does, what the options do, or the options for any kind of alternative commands do, and then we get a bunch of examples as well. So plenty of detail, and it should, in general, help you to use any command that you already know the name of. If you don't know the name of the command, you can just type help and then typing something in to the search window. If you want to know about opening a dataset, it brings up search results, and the first one is opening and saving Stata datasets. I can't guarantee it's always going to be this helpful. Sometimes it can be a bit tricky to use, and you might need to go online to find out which command you want to do a certain thing. But once you find the command, then the help system is nice and helpful. Okay, that's about it for the help system. I encourage you to have a look at the help file for any of the commands that we use that you want to know more about, just because they are actually helpful. Okay, 1.7, the working directory. So the working directory is where Stata tries to find all of the files that you're currently using or trying to load, unless you give it a different folder, there we go, to look in. You can see it in the bottom left of the screen. It's currently just looking in my documents folder. Often this isn't where you want to be looking, so you can change the directory by using the cd command, which is just short for change directory, and then providing a folder. If you've already used a file, loaded a file into memory, then you might have the entire folder location that you need, in which case you just select the entire folder location, put it in quotation marks with CD at the front, and put it in, And you can see the bottom left-hand side of the of Stata is now showing me that I'm looking in, or Stata is looking in, the folder where I have saved the data files for this lesson. This means that if I wanted to open the file again, and I was feeling like typing it into the command bar rather than using the open button, there we go, I can use the file that I want, and it didn't come up with an error message because it loaded it straight into memory, and I've saved a whole bunch of typing if I were typing it all out. In general, it's good to change the directory to the folder that you're using. It just makes things, it just tends to make things easier. So if you haven't already loaded a file into memory, you can copy the entire folder location from just a general Explorer window by selecting everything in the kind of folder location of this window. There it is. Okay, that's probably enough about everything that's not actually looking at data. So section 1.8, looking at your data. Stata can very much be thought of as a spreadsheet where there are some number of columns and some number of rows. The columns are the variables, and they're all listed on the right. The rows are the observations. When we create variables in Stata, there's a very specific kind of setup that you need. So each variable has to have a unique name. That's kind of the first rule, because you need to be able to specify each variable uniquely. And there are rules about what they can be called. So variables have to start with a letter or an underscore. So you can see all of these variables start with a letter, I think. Variables can't have more than 32 characters, so they can't be too long. Variable names can't be used more than once, they have to be unique. And variable names can't have spaces or symbols in them, with the exception of an underscore. So you can see I put an underscore here instead of a space. If you put spaces between, or if you try to put spaces between variable names, Stata would get confused and think you're referencing two separate variables at once, which is not good. Stata is also case sensitive. So if you have age with a capital A and age with a lowercase a, those are both unique variable names. They could both exist in this data set. But in general, it's much more confusing when you mix upper and lowercase letters in variable names. So as a rule of thumb, I always have lowercase variable names. Okay, so the data can be viewed. This is a very useful thing when you've just loaded a dataset into memory to check that it looks like how you're expecting it to look. There are two buttons we could press to load up basically the same view. These are the data editor buttons. The one on the left is for edit, the one on the right is for browse. With the edit, I loaded it up but it came on a different screen. With the edit, you can directly change what is in each cell. This is highly not recommended because it's really unreplicable to directly edit what's in each cell. Stata does make a record of it, and actually by the end of the second lesson you'll know exactly what that means. But in general, avoid directly editing data. Sometimes it can be useful, but often it creates more of a problem than it solves. So often we load up in the browse view. The only difference between these two modes is that in the browse view you can type all you like, but nothing's going to change, and it's going to make a noise at you. So I would recommend using the browse mode rather than the edit mode, just in case that you slip on pressing an S or a 12. But in any case, we can see the data in this, what I'm going to call spreadsheet view. So we can see some of the variables are filled with black text, some are filled with red text, and one of them is filled with blue text. The black values are all numbers, so you can confirm that for yourself. They are all numbers, with the exception of ones that have full stops in them. In Stata, a full stop is a missing value, so there is no value for variable 13, var13, for the first observation here. It's missing. Missing values in Stata are actually coded as very, very large numbers close to infinity, which in general won't cause a problem, apart from when we deal with if statements, and we deal with those in lesson 3. So for now, missing values, number very close to infinity, that's just missing. Stata ignores them for the purposes of almost all calculations it's doing, and it treats them as they should be treated, which is just missing. Okay, string variables, so variables filled with text, are red. So these variables are treated very separately to the black variables, the numeric variables. And whenever you're dealing with string variables in Stata, the kind of what you need to bear in mind is that you'll need quotation marks with virtually everything. Now, most of these actually look like text. So we've got colors, male or female. This is a date, so dates are dealt with quite interestingly in Stata, and we come onto that in a later lesson. Income is treated as a string because it's got words like 2 in it. Calories, however, looks like it's all numbers, although there is an NR there, so that's why it's being treated as a string. Whenever you load data into Stata from somewhere that's not Stata already, anything that has text in it rather than just numbers will be imported as a string because it then preserves the letters. So the numeric variables just can't have any text in them at all, ever, with the exception of, well, sort of the exception of labeled numeric variables. So these are blue, and these are actually numbers. So you can see up here, the value in this cell is 1. If we go down 1, the value in this cell is 3, and then 1, 1, 1, 3, 1, 2, 2. You can see it changing up here. So these are numbers that have been labelled. So every 1 has the label own, every 3 has the label rent, and every 2 has the label mortgage. This variable, incidentally, is accommodation. So that makes sense. It means when you're using this variable and looking at it, it's, for all intents and purposes, a number. The only distinction is, if we were to summarize it or create a table with these values, then instead of being the 1, 2s, and 3s that it actually is, it will show you own, rent, and mortgage. This can be highly beneficial because it means that instead of having to remember what 0s and 1s mean or 1s, 2s, 3s mean, it comes up with exactly what it's supposed to be showing, but you can still use it as if it's a number. So you can use it in things like regressions and other analyses as if it were a number. Okay, I think that's everything about the spreadsheet view, so let's close that. So in the edit view I did make some changes, but I made them all. I made them and then reset them, so this is all correct now and we can ignore it. So moving on to section 1.9. Importing, exporting, appending, and merging data. This is the last section, I think, for this lesson before we move on to the exercises. So, importing data. Stata can obviously load in .dta files because that's its own format. But you can also import files from Excel and files from text data that's got delimiters CSV files, comma separated value files, or tab separated value files, they can all be loaded into Stata. Often the easier way to import files is to go into File, into Import, and then select the data type that you're looking at. So let's try it with an Excel. Let's try it with text data first, because text data tends to be simpler than Excel data. So I've created a CSV file and an Excel file for us to try and import. So let's try that. Good, it's remembered where I was last time I opened it. That's good. So let's open it. It might take you a while to navigate to, because this browse window is pretty old-fashioned. But once you're there, you get all of these options. But for kind of for a first look, just look at the preview and see, does this look like the data that I want it to look like? Is this what I'm expecting? So here we can see that each variable has a name. That's good, because that's what we want. We don't want it to be called random things. And within each variable, it shows us whether it's going to be numeric or a string. And we just look across. We can see accommodation is a string. This is because in a CSV file, we don't have labels. All we have is a string that says own, rent, or mortgage. So it imports it as a string. We can then, if we're happy with this, we can select OK. If we're not happy with this, we can play with these settings. Let's just try doing it. Data in memory. Do you want to continue and replace data in memory? Stata is very vigilant about replacing or overwriting any data, so these types of messages appear a lot. But yes, we're happy. So it's then created what the command actually is for us down here. So the import command is actually import. We then specify the type of thing we're importing. Delimited is things that have delimiters, like commas in a CSV file or tabs in a TSV file. The file location, again, very similar to the use command. And then comma clear, because we had data in memory and we're overwriting it. We can take a quick look at the data, and it looks pretty much the same as the dataset we loaded in first, with the exception that accommodation is now a string instead of a numeric labeled, or a labeled numeric variable. So good, that's pretty much what we wanted. And now we have this command. We can copy it into a do file, or we can remember it and use it later rather than having to go through the import function. And we can do the same thing for the Excel file. Import Excel, select the file, so lesson 1 in the Excel 1997 to 2003 worksheet. File format. We then select which worksheet we want. There's only one, but if there were more than one, we could select which worksheet we wanted from within the file. We can also select which cell ranges we want. In this case, we want everything, so that's A1 to P1001. However, you can see that the first row of this data is actually the variable names. And there's an option here, import first row as variable names. We select that, and it's now got the first row in the Excel document as the variable names. Unselect it, and suddenly everything is called A, B, C, D, E, F, G, like it would be in Excel. You also have the option to import all data as strings, rather than importing numbers as numbers and strings as strings, which could be useful, you never know. Select OK. Data and memory have changed. Do you want to continue and lose unsaved data? Yes. And here we get the command again. This time it's import, but we're importing an Excel document, so import Excel. File location, same as it was before. Now we have to specify the sheet that we're looking at, so sheet 1. I think you always have to specify this, even if there's only one sheet that you're looking at, but not sure. We also have the option first row. First row is the option that means that the first row in Excel is treated as the variable names in Stata. So it's not imported as the first observation, it's imported as the names of the variables. And the clear option that we've seen a few times before, that means we're happy overwriting the data, please let us do it. Okay, so that's importing. Exporting data. So if you need to go from a data format to an Excel file or a CSV or anything else, it can be done with the export function or export command, which is very much the opposite of the import command. So if we want to export to an Excel spreadsheet, we can using this quite difficult looking form. All that we need to think about is what do we want to call it. So let's just do this, lesson 1 underscore sh, and I don't want to specify a worksheet name or a starting cell, but I could if I wanted to. Allow a worksheet to be modified if it already exists, so you can use Stata to output an Excel spreadsheet, and you could have different data sets in Stata populating different spreadsheets in an Excel spreadsheet. Yep. And all it does is modify it. So if you didn't select the modified if it already exists option, then it would overwrite the entire spreadsheet, but you just want to add a sheet to the spreadsheet so you can modify it. And you can replace the worksheet if it already exists. That's Stata trying to preserve data so you don't accidentally overwrite it. And then we have the save variable names to the first row in Excel file, or save the variable labels to the first row in the Excel file. So on the right, you can see the variable names and the variable labels. They're all the same because we just imported this from Excel. But if we had the original dataset open, the labels did look different, and you can export those instead of the variable names. Output numeric values, not labels of labeled variables. We'll cover labeled variables in more detail in another lesson. And finally, overwrite the Excel file. That's Stata again, trying to stop you from overwriting things you don't want to. You then have some more advanced options, but we won't look at those now. But let's just tick save variable names to the first row, and that should work. We can open up the file. We can open up the file, take a quick look, and it's pretty much as we'd expect. All the variable names at the top, and all of the values for the variables going down all the way to row 1001. Feel free to peruse at your leisure. Okay, we can also do the same thing with a CSV file. So if you wanted to export text data, delimited, save as, not entirely certain why that gave me an error message, sh.csv, actually it's already saving as a .csv, so we don't need to specify that. And we want a comma separated format. Do not write variable names on the first line. That's kind of the opposite of what it was in the Excel file. That's kind of unhelpful. And I don't want any of those other options, so click OK. And then let's take another look at, there we go, Microsoft Excel, comma separated values. That's the CSV file we just created. And that's, make that a bit bigger. That all looks the same as we exported to Excel, but now it's a CSV, and that's generally the easier type of file to work with. Okay, that's exporting data. Appending data. So I don't have an example of this, but there's one in the exercise. That'll be fun for you. So appending data. If you have multiple data sets that have the same, there we go, the same variables in the same formats. So if you have an age variable, then age is in numeric in both one data set and another saved data set. Or you have sex and it's in string in one and string in the other. So same name, same file, same variable type. then you can stack them, put one data set on top of the other. It's called appending, and the command is simply append, and then the word using, which in Stata means using a particular file. So please append the dataset in memory to another dataset called, and then you type in the new dataset name here, including the folder path if it's not in your working directory. When you do that, it just sticks one dataset on top of the other. If you have missing values, or if you have missing variables, sorry. So if the new dataset contained those variables, the first 13 variables, but not current smoker, favorite colors, or date of blood pressure measurement, the new dataset will still load in beneath this dataset, but the values for these three variables would just be missing for the observations in the new dataset. So append is pretty simple. The final bit of lesson to cover is merging data. So appending is stacking one dataset on top of the other. Merging is adding variables to an existing dataset based on some unique, usually unique variable, usually an identifier variable like ID. So let's load back in Let's load back in the lesson that we saved our initials to. So lesson_01_sh. I'm just going to drag and drop. I do want to continue and lose unsaved data. Thank you, Stata. There we go. We actually get the variable labels now. So variable 1 is the ID number. It's currently named poorly, and that's something that we're going to fix in the next lesson. But this is the ID number. It is unique for every observation, and what we have is another data set that has those same observations but tied to a variable that we don't have in this data set. So we want to merge the two data sets together. So let's just take a look at the file we want to merge it with, and it's just the file called merge. Let's have a quick look. So this is just a list of ID numbers tied with date of recruitment. So it's this is the same variable that we have in the first lesson dataset, just tied with a new variable. So let's load back in. Okay, let's load back in lesson_01_ your initials. And helpful tip: this review window listing all of the commands that we've put into Stata, you can just click on it and it brings up the command that you typed. So if you want to do something again, like load in not a data set you've already loaded in, click on it here and jobs are good. So merges in general can be one-to-one, where you have one unique identifier in one dataset and the same unique identifier in a different dataset, and you match the datasets on those values. They can also be one-to-many, where you have your original dataset. I think it's this I know. You have your original dataset, so our lesson_01_sh, and that has a unique list of identifiers. You might have another dataset where each identifier, there are many rows with the same identifier in. So you're merging one to many. Alternatively, you could have many identifiers in your first file and only one in your second file. So you're merging many to one, or you can merge many to many. But in 10 years, I don't think I've ever matched many to many. I've often matched one-to-one because I often have data that is in separate files and I need to combine it together. And I've used one-to-many and many-to-one matching as well, because sometimes you have examples where you have a single observation because it has, say, demographic information about a person, where it has their age, sex, height, weight, what have you, at one point in time. And then you have another data set that has lots of observations for that same person. Like maybe they did an exercise study and they measured their heart rate over 20 minutes and it has one observation for every minute. So you've got 20 observations for each person. And now you want to match those two bits of information together. So it'd be one to many. Or vice versa, you might start with the heart rates and add on demographic information. You can also merge just on row number. So if we were absolutely certain that every row in our first data set matched the row number in the second data set, we can match just on rows. So it'd be like taking two spreadsheets and just pasting one after the other. There's no matching when we do that. So that's the in the course book, merge one-to-one underscore n, where underscore n in Stata language is it refers to the observation number. So you can see on the far left here we have the observation number. This is the same as the ID number in this data set because that's how I created it, but obviously it doesn't have to be. Okay, so let's try merging these two data sets. We're actually going to type it out this time. So we have our command name, merge. We have the type of merging we want. So this is one-to-one, one-to-many, many-to-one, or many-to-many. But we want one-to-one. And we want to do it based entirely on variable 1, which is in both data sets. So both this one and the merge data set, we checked that. So merge one-to-one on var1, and then we have using, because we're specifying a particular file, using merge underscore 01.dta. And then it says file not found, because it's literally just called merge. Well, there we go. 99% of the time, when errors are made in Stata, it's because of typos like that. So, merge one-to-one var1 using merge.dta. And then it brings up this kind of table as the results. And it tells us how many of these observations were not matched. And it tells us that 83 observations from the master dataset, so the first dataset, the lesson underscore 01, it tells us 83 of those observations weren't matched with the dataset we just merged in. It then tells us from using 0. So this means the using dataset is the one that we specified here, so using the merged dataset. It tells us that no observations were missing, no observations were not matched. So every observation in the merge.dta file was matched to something in the lesson underscore 01 file. So no missingness there. And it tells us that 917 observations were matched. We started with 1,000 observations, and 917 plus 83 is 1,000, so it is giving us information about every observation in this data set. We can also look at it. So before, that was our data, 16 columns, 16 variables. But now we have another variable called data recruitment. This is the variable that was merged in from the merge.dta file. And we also have a Stata generated variable called underscore merge, which tells us for any individual observation whether it was matched between the data sets or whether it was found just in the master dataset, so the first dataset we started with. And you can see that for observation number 8, it says master only. So this has a missing value for data recruitment because it wasn't in the merge.dta file. We know from the table that Stata presented us with that every observation in the merge file was already in the lesson file. So there won't be any 2s here, but there are 1s and 3s. Remember, this is a labeled numeric variable because it's blue. So 3, you can see it's matched, and 1 is master only. It even has the number, helpfully, at the end here. Okay, that is pretty much everything. If we have a quick look at merge file, this is one that if you are merging regularly, you may keep coming back to, because there's quite a lot of information on this page, and there's quite a lot of options as well. One of the options, no generate, do not create the underscore merge variable. That simply means do not generate the underscore merge variable, so Stata won't do that. I often do this because I don't want that variable. Yeah, it's a helpful option to use if you are merging lots of files. Okay, that is the end of kind of the lesson component. The last thing we're going to do is we're going to resave the dataset because we've now merged something in, so we've made a change. Let's save it because we'll be using the same dataset in the next lesson. So I can actually just hit save. Do I want to save it? Yes. I could have also typed save lesson 01 sh.dta with the option replace, and it would still come up with lesson saved. Good. Okay, so in the coursebook, section 1.10 is the exercise. Have a look through, see how you do. The answers are in the following section on the following page, but have a go at them, and then we'll go through the answers. So I'm actually going to leave this for a few minutes, give you time to go through it, and then we'll come back with the answers in a few minutes. Okay, welcome back everybody. I hope that went well for everyone. So, we're just going to go through the answers to the exercise 1.10 now. First question, open a fresh copy of Stata. Okay, I've already closed my version of Stata, so open up a new one. Incidentally, I've made all the text here bigger, so it's easier to see on smaller screens. Yours may look kind of a bit zoomed out compared to this. You can change the font by right-clicking on any window and changing the font settings. I think you can do it with all the windows, apart from the properties window, which doesn't seem to be able to be resized. Okay, so open a fresh copy of Stata. Question 2, change the directory to the folder containing your downloaded copy of the exercise 01 dataset. Can do. So let's open up the folder where you've downloaded all the files. Click into this address bar, copy the text, and we're changing the directory, so that's the cd command, and then in quotation marks, just the name of the folder that we want to change the directory to. When it's done, you can see it on the bottom left, we're now in the right folder. The exercise 01 dataset, very similar to the lesson 01 dataset, but changed, some variable names are changed, and what you have to do to it is quite different between the exercise dataset and the lesson datasets. So you won't have, you can copy commands, but you'll need to apply them in different settings. So it's not just copy and paste, it's copy, paste, and edit. Question 3 though, load in the exercise 01 dataset. I usually just like to drag and drop, but you could also use this open button, click exercise 01, or you might have typed out the command use, because Stata doesn't use open, it uses use to open datasets, a bit confusingly, exercise 01.gta. Remembering capital letters matter, Stata is case sensitive, so if we try to do it with a lowercase exercise, oh actually it does work. Well, thank you Stata. For file names then it doesn't matter, presumably because file names are not case sensitive, whereas Stata is. That's good to know. Okay, so in any case, we've loaded in the exercise 01 dataset. Question 4 is save a copy of the dataset with your initials at the end. Let's type that one out rather than using the save button. So save exercise _01_sh.dta. I'm going to add a replace option in because I already created this, but you may not have needed it if you weren't overwriting any data. Okay, so it's saved. Let's just take a quick look. Exercise _01_sh, saved at 222. It's now 223, but yeah, that must be the one. Good. So that is saved. And so we can work off this and not worry about overwriting data in the original master copy. Okay, question 5, have a look at the variables listed in the top right window and the dataset information in the bottom right window. So top window, we can see we have ID, age, sex, height, weight, hair color, pretty much everything we had in the original dataset. Although we don't have any date variables. And some of these variables look like they're in different units. So age isn't in years, it's in months. Height isn't in centimeters, it's in meters. Weight isn't in kilograms, it's in stone. And question 6 is take a look at the data using the spreadsheet view. So data editor or spreadsheet view. Let's take a look. First thing to note is we start at ID 501 rather than 1. That should become clear in the next question why that is. We got some black values, so black text. These are numbers, straight numbers, no labeling or anything. We have one string variable, so that's in red, and we have 2 labeled numeric variables. So these are numbers, and you can see that they're numbers because the values it displays at the top. Grey is 4, brown is 2, 2, 2, red is 5, black is 1. So these are numbers that have a label applied to them to make them appear more informative. And the same with accommodation, which is the same as in the lesson dataset that we just looked at. Okay, question 7, append the exercise 01 append dataset. So here we can use the append command, which is append, and because we then are specifying a file, append using, and in quotation marks, exercise 01 append.dta. The .dta isn't necessary, but is good, nice for completion. And it tells us that label hair color already defined and label accommodation already defined. These are the labels for hair color and accommodation. They exist both in the original dataset and in the dataset we just appended, and so it just gives us a note saying it already exists. We'll find out how to create those in the next lesson. Okay, so we had our 1,000 observations. Scroll down. So we had our 1,000 observations going from 501 up to 1,500, and now we've appended to that 500 extra observations with IDs 1 to 500. So clearly at some point these data sets were cut apart, and now we've joined them back together again. Okay. Question 8, merge the exercise 01 merge .dta dataset. This one, you may want to just take a quick look at merge before merging it. Quicker look at the merge dataset before merging it. You can either do this by loading it into this data window, or we could load up another copy of Stata. If we can hit the right keys, load up another copy of Stata, load it into the new copy of Stata, just take a quick look. Okay, so we've got an ID variable and we've got date of recruitment. Good, so we can, we know that the ID variable is also in the original data set, so we have something to merge with, and we know, or we can at least guess that ID is unique, and so we should be able to merge one to one. We don't need this copy anymore. There we go. So we are now merging the data sets, and the command is merge. We're merging one to one because we're merging unique values of ID in the original data set and in the merged data set. So we specify which variable we're matching. Merge one-to-one ID using, because we're specifying a file, and it's the exercise 01 merge.dta dataset. Okay, we now have 1,500 matched observations, so they all matched, which is nice. We can take a quick look. So we have all the variables we had before, as well as now date of recruitment and the merge variable, which tells us universally that all of these observations matched. Same information we have there, all of the observations matched between the two data sets. So full merging. You can see that the date of recruitment is a number, all in the 21,000s. Dates in Stata are coded this way. They are numbers which then are formatted to look like dates. It's actually the number of days since the 1st of January 1960. We'll find out in, I think, the third lesson how to format that so it doesn't look just kind of silly. Okay. Question 9 is open up the help menu for merge and take a quick look at the available options. See if you can figure out how to merge a dataset without creating the merge variable. Okay, so help is just help and then the name of the command you want help for. It brings up this page, and you'll remember earlier I went through this and said the no generate option is quite a useful one because it allows you to create to merge datasets without creating the underscore merge variable. So we have already merged, but if we wanted to merge without creating the merge variable, we would put in an option, so put in a comma, and then the option no generate. And this would change the command so we didn't create this variable here, the underscore merge variable. So let's, yes, of course. I will go back through this and create it just to show you how it works. Start from fresh, use the exercise underscore o1.dta dataset. May as well do everything. Save it with my initials. Append using the exercise o1 append dataset. Merge, but this time with the option no generate. It doesn't give us any extra information, and it still just tells us 1500 observations matched between the two datasets. But there's no merge variable. So if we don't need this, and this time we didn't because we matched all 1500 observations, we may as well not create it. So all that's changed is we have the date of recruitment added as a variable. Okay, question 10. Save the appended and merged dataset, so this dataset, with your initials again. So always good to scroll back through your commands in case any of them are relevant. Or if you're using a do file, just copy the same bit of text, the same command. So we're saving it, exercise underscore o1 underscore initials, saved, good. Now, question 11, export this dataset to an Excel spreadsheet and make sure the variable names are in the header row. So file, export. You could have been able to do this using the commands that we went through earlier in the lesson. If so, well done. Otherwise, you can use the export function. So export as, let's call it the same thing, exercise o1 underscore sh as an Excel workbook, that's fine. And make sure the variable names are in the header row. Save variable names to the first row in Excel file. Any other options look like they'll be useful. Allow worksheet to be modified, that doesn't count. Replace worksheet if it already exists, it doesn't, that's fine. Output numeric values, not labels, of labeled variables. Nope, I want the labels. And overwrite Excel file, it doesn't exist, so that's fine. So all I've done is gone save as, selected the file name I wanted, and ticked the box, save variable names to first row. So export Excel, that's the command, using, and then listed off the file path that we need, comma, because these are options, first row, variables. And we can take a quick look, exercise underscore o1 underscore sh. And here we have, first row is the variable names, that's good. And I should have 1500, there we are, 1500 observations. Good. I hope you got an okay with that. Yeah, if not, feel free to ask me questions in the on my Twitter. Otherwise, I hope this was useful and see you again for the next lesson.